And thank you, Rodolphe. Thank you. Thank you, Rodolphe. So thank you for the introductions. We will speak about something quite new, being able to choose between new solutions to execute our tests. So it asks a new question, and why do we need a script for every test? We will just discuss about this in the angle of not having an opposition between two solutions, but see how it can be complementary. So agentic test execution and AI-assisted scripting. And just before, a few words about smart testing. We are a French software publisher, and we are a bit more than 10 years old now. And we started, research on AI dedicated for testing since 2K18. So we didn't wait for ChatGPT, to start with this. And what we want is to provide the best tools to software testers and to innovate and reinvent software testing practices. So we have a visual test design tool with Jest, and here we will specifically talk about something new that was released at the beginning of the year, agentic test execution with Lynqa. And okay, we will discuss about first a sentence I hear since quite a long time. Every test should be scripted. And then we will do a small comparison with a robotic lawnmower effect. You will see where I would like to get with this. It will introduce agentic test execution, and we will have a short comparison with AI-assisted scripting. We will conclude in the end and have a few takeaways. So we will start. It makes many years that I hear, every test should or will be scripted. It's a prediction we have for the past 20 years. And it started when we started to automate tests in the early 2K years. And then we arrived with agility, and agile teams told, okay, we will make manual test obsolete. CI/CD became the norm and the rule, and DevOps increased, and everybody said, okay, we will execute all necessary tests from the CI. Now, at the age of AI, we heard manual tests will disappear, or you will have nothing to do to have automated tests, almost nothing to do. Now we can see those years that AI-assisted scripting has a huge impact. And what's about AI-assisted scripting? Does it resolve all our needs for execution? First, AI-assisted scripting is an approach to accelerate the creation and the maintenance of your automated functional tests. So to give an example, if you give some input, some test intent, requirement, user stories, AI will help you to generate code. It will get for you the good selectors. It will add some assertions. It will help to generate data. You need to still verify that the test check the right behavior. And then if you need some maintenance, you will also have something more. AI will help you with self-healing, for instance, of locators. And we have huge gain for this, thanks to this. And then you have a loop to maintain your tests. So at several stages, AI helps a lot when you automate your tests. But I tell that's a partial solution. Even if we have, modern frameworks, as we have Playwright, that is a real good framework, or others, and we have AI-assisted scripting, but it has some limits. Sometimes you have some unpredictable pop-ups that arrive, or you have some visual assertions to do that are quite hard to automate. And you have to be careful because even if it's AI assisted, you still have a cost to produce your scripts and to maintain those. That's not a solution that reduce and remove all the costs. And this cost makes important to choose when to automate your tests. If you automate too early, you will create a debt that you shouldn't create if you're, for instance, your UI is not really stable or your feature have a lot of evolution and you will need to maintain again and again. Even if assisted, it will be a cost. So every test should not be scripted. And in practice, what we can see is that a huge part of the functional tests are still executed manually in the companies. And that means that manual tests still exist. And why and how could we help on those, for instance? So we will see how AI could help. First, how AI is used, for functional testing. We can see a lot of things done on user story optimization. We heard about Force Amigo, during the meetings with the Tree Amigo, an AI that could help you to discuss and ask you questions to refine your user stories, to find inconsistencies or and create better user stories. And that's the first use we have with AI. Then we have a use with AI with test scenario generation. It could help to create natural language scenarios from user stories, specifications, scripts, or whatever. And here, that's a huge gain with AI also, but we still have to master it and to manage correctly. And then why not using AI to directly from those test scenario create scripts, so test execution scripts in whatever language, and why not using AI to come directly from user story to scripts? That's the main idea. And AI assisted scripting is this one. So we could imagine another solution because we obtain potentially test scenario when we create, we use AI or we write it manually. Why not running those test scenario directly without automating them? That's here that agentic test execution comes into the picture. Okay, so now to illustrate this, I will speak to you about, I bought this kind of lawn mower. The idea is quite simple. I need a very few setup to make it work. I just remote guided this. I did a lap around my garden and it was done. I kept control. I defined some areas. I set boundaries, and I check what the robot does. Actually, it works independently and just reports me. It tells me how it progresses. And if it has a problem, I assist it. When something goes wrong, it can learn to avoid obstacles and do elsewhere and so on. So that's a real solution for me. Why is it a solution? Because it saves me a lot of tedious tasks and tiring tasks. And now I can use my time to do other tasks, taking care of the garden, vegetable garden, rearranging the garden and so on. So it replaced the tedious tasks and saved me some time. Now what if a robot could take care of my execution? It's why I want to make you a parallel with that. If I had, let's say, an agentic tester, I would choose which test to delegate as I choose the zone and boundaries to move. I will follow, I will ask the agentic tester to follow a test scenario. It will click for me, fill forms, and so on. It saves me this tedious task. I don't want to do it manually each release, so it can save me a lot of time. I could review the results. It could give me execution reports and screenshots. It could also let me do some additional checks, visual checks, on also check the UX or if some runs are inconclusive. And if it misses some context, I could unblock the agentic tester. And for instance, I will use my time better. I could do exploratory testing. I could increase test coverage. I could automate tests by create scripts with perhaps AI assisted scripting. So that's the real parallel. And agentic test execution is something that exists now because we now have AI agents and specifically computer use agents. A computer use agent is an agent that can control the computer. It is specific because it's a kind of agent that have some tools that enables it to interact with the computer, but it can also perceive the computer, observe, and it has a memory. So I could, with this agent, send some task, let it reason and plan, use the tools and perceive its environment to do some actions, and it could dialogue with me so we could go one step after the other and do some tasks. Here we speak about computer use agents, but we need an agent dedicated to testing and not, generic agentic, generic AI agent. Because if you run an agent, it could take too much liberties. Here, an agentic tester must preserve the original intent of the test, and it should not take too much liberties. I don't want it to go through my vegetable garden if it was a robotic lawnmower. That's the same. I want the agent to stick on what is specified in the test and to act like a human tester and to respect the original test intent. Okay, and that's what we built with Lynqa, for instance, here. I will show you it directly live now. We have a version of Lynqa that is integrated into Jira directly, and that could execute your test directly from natural language or Cucumber test in Gherkin, and give you screenshots and proof and evidences about what has been done. You could also, and you will see if you want, you can go and follow the links to try Lynqa by yourself on this address, okay? And for this example, we will ask for a journey on the Google Maps. We want to create a journey from the railway station to the smart testing office. And we will ask to check duration and direction. Very simple tests, but that's not so easy to, to automate on Google Maps because of the IDs and everything moving, and yeah, it's not so easy. And we will see how it works, and I will explain to you. Simple test, but it will give you the concept. So let's say we are here in Jira, and we already have installed X-Ray, we installed the Lynqa application that is available on the marketplace. And Lynqa is able to read tests in X-ray and execute those tests. So for this example, here we will open a test. And you will see that first, you don't need to express each field, each button ID, where to click and so on. You can stay at a high level language when you speak, more business level language. And if you express a test like this, reject the term, then search for the provided address. We will use the railway station that is in the data. And you should check the expected result that the good address is displayed. So, I don't tell the field is located like this with such selector. I just tell to reject terms and to search for the address. Then we will create a driving route. We want to go from the train station that we defined before to the office address. You can use the switch to change the direction. And also, you will need to check that the journey is less than 20 minutes and goes through a specific road. Okay, so we have this simple test description. We will not see the other steps. In X-ray, you could create a test execution card. And this card is specific because it groups some tests. Here we have 2 tests. And you could launch the test execution and execute manually your test. What Lynqa does is it adds a button. Okay, with this button, you will be able to choose, for instance, a test execution context and tell where Lynqa should execute those tests. Here, directly, we will execute on Google Maps. The browser language will be in English, and here are the 2 tests that should be executed. You can choose, for instance, to execute sequentially or to parallelize the execution. Here we have chosen to execute the test in parallel. And Lynqa will tell me now, I launch the 2 tests. And you will see something that is really different from execution from automated tests. Here, the execution time for one test is more comparable to a manual tester. So it will be a bit longer. And that's why we will speak about it after. That does not compete with test automation. That's more a new way to execute your tests, and that's more complementary. And here, for instance, our 2 tests are executing, and I will open one of the 2 tests. And I will explain you how Lynqa works. First, it starts by opening the URL I asked for. And Lynqa here will show me a screenshot about what has been done. Then it will reject the terms. It will read the action. Here, the action was reject terms and search for the provided address. So it will explain me what it does to do this. And Lynqa tells me, okay, to reject the terms, I need to scroll down here. And then I will reject because I really understood that you wanted to reject. Then I need to fill the provided address. Lynqa will find directly here the field. It will, for you, fill the address. It will select the good station. And then it will give you a screenshot showing you the address that you asked for. And it will tell you, okay, we have verified the assertion is correct. And you can see while I'm speaking that Lynqa is continuing to execute your test. So as a summary, it reads the action. It explains you how it does the actions. And it will read the expected result and do the checks and give you a proof and evidence at each stage. Now, if we are looking for this second step, Lynqa will just continue and click and select the fields and so on. Here, that's a test that will be a success. We want probably to see more what happens when the test fails. I launched the 2 tests, and the second one, I asked for an impossible duration time. So Lynqa will execute in parallel. So you can see that I can go directly to each test and see the test evolution while it's executing, or I can also see my previous runs and browse my previous runs. If I open this one that is finished, I will have a way to check what Lynqa does when the test fails. Here, it did the same thing, but I asked for a journey that is less than 10 minutes. It's impossible because you wouldn't have time and enough time to do this. Lynqa is able to interpret and tell you, okay, I can see that you ask for this road. So Lynqa asks to check that we should go through this N57 road, but it's able to interpret that 11 minutes is more than the requested 10 minutes. And it will give you a plain natural language text to explain to you. Okay. So once this is done, you could save your result directly into your test management tool. Here, that's for X-ray. And see that Lynqa is able to fill what has been done, what has been checked, and if needed, it can give you an evidence and attach a good screenshot in your test report. Okay, so that's how Agentic test execution works. It reads your test plain natural language. So for instance, here, Alice could choose to launch 42 tests in parallel. Lynqa will read the tests, the instruction, it will perform the requested actions and checks. It will provide clear evidence and traceable proof of the execution. In the meantime, Alice could spend her time to do something else and do whatever she wants on higher value tasks. I think she could do exploratory testing, automating more tests, or do something else. And then Alice will come back, view the results, and perform additional checks if she would like, adjust the report, and that's it. So the idea is to save a lot of time about test execution. Now, if we compare to AI-assisted scripting, we have 2 approaches using AI to help for test execution. And we have really 2 different approaches. The agentic test execution is a way to directly run on the UI as a human would. It will take as an input lateral language or Gherkin, and it will give you as an output your test verdict with screenshot evidences. On the other hand, we have AI-assisted scripting. The AI copilot will help the test engineer writing the scripts, and it will take as an input perhaps some existing tests and code, or Gherkin or test specification. And as an output, it will create some maintainable scripts in the framework of your choice. And that's important also that this AI-assisted scripting will help you with self-healing, for instance. And we have those 2 approaches, and both have some strengths. First, perhaps the 2 approaches won't be used by the same users. You can use agentic test execution when you are a functional QA or test analyst. For AI-assisted scripting, you need to have skills and automation skills, okay? And so that's the thing with agentic test execution. If you have a domain language that knows to have the tests and to create the test and to learn this, you just need to have this test expressed in natural language. You need to be to have programming skills when you want AI-assisted scripting. A big difference also is when you are using a CI/CD that's native, when you use AI-assisted scripting. And also, it will be better to use this because test execution will be very fast. And if you want a very short feedback loop, you would have to prefer this AI-assisted scripting. For agentic test execution, CI/CD could trigger your agentic test execution also. And then the angle is different when you need to maintain. On one hand, with agentic test execution, you will maintain test data, you will maintain test intention. You could be assisted by AI to do so from specification, for instance. On the other hand, with AI-assisted scripting, you will have assisted self-healing. I just had a small warning on this. When you automate, you transform a test intention into a sequence of technical actions. So you need, with self-healing, just to be careful to not lose the original intent of the test if you fix some technical change. So perhaps you need to name very well your keywords so they are expressive enough for the framework you are using and the AI to be understandable and to keep their original intention, or you need to document or give documents and so on. Okay, so we have strength on one side. But now, how to choose between those two solutions? First, we have agentic test execution on the left and AI-assisted on the right. And we could take a first dimension, the time to execution. What is a time that is allowed between the test creation and execution? If I'm, I'm doing a sprint and we just redacted the test and we need to execute it now, we don't have a lot of time. Or we have this test that we already have executed several times manually, for instance, and we want to make it automated because it's stable enough and we want to reuse it each time. Depending on this, you will go, if you need to execute immediately on the agentic test execution side, else you will go on the AI-assisted scripting. Another dimension could be the cadence. If you need to execute your tests several times per sprint or only once or twice per sprint, you would use either agentic test execution or AI-assisted scripting. Then you have your UI or features that can be stabilized or not. You could have a real young feature that will move, evolve, selector will change a lot, and also user experience will change. In this case, you would use agentic test execution. If the UI is really stable, you should go and script your tests. And last dimension, if your Oracle is really strict, agentic test execution could check exactly what was asked for, as AI-assisted scripting will do. But if you have something more loose, like just a confirmation message should be displayed, something less less precise, agentic test execution is also able to do this. Okay. If we have those 4 dimensions, you could use by yourself. I give you a link. We just provide this small tool, so you could try by yourself to define some cases, and we would provide to you some recommendations. So it's a kind of decision matrix to know between using one approach or the other. Okay. So as key takeaways, I will speak about the e-scooter effect. We had pedestrian and cyclists before, and the e-scooter arrived, but it didn't replace all the pedestrians or all the cyclists. It added a new option. Agentic test execution will not replace manual testing or AI-assisted scripting. It's a new execution option. It's a new way to execute, and it could be complementary. The question changed and is no more what is the most appropriate way to execute a test. Okay. And here we can have a clue. You can use the decision metrics I gave to you. And as a reminder, if you have some repetitive regression testing with really stable and deterministic scenario that you need to execute really often, and you need a real feedback loop very fast from the CI/CD, you would go to an AI-assisted scripting. If you have UI-based functional testing and you have a new feature or an UI that is really moving fast, you already perhaps have natural language or Gherkin test scripts, and you want to execute, but it's quite difficult to scale because you have not a huge number of manual testers. You could parallelize, for instance, with agentic execution. Here you would go to agentic execution. And for the rest, for user experience or really exploration or some complex business logic, you will go to manual testing. Okay, and the idea is more here as a conclusion, to not use only one or the other, but to combine wisely each technique. So I hope it suits to what you expected for this. I will try now to answer to the questions.